Welcome to part 4 of learning to program math functions. This time we're going to be talking about programming trigonometric functions. So let's begin. I like particularly well coding the trigonometric functions because in the course of doing it, I learned the value of a lot of the formulas that we had been taught and was able to use these in developing programs for these functions. So today we're going to be talking about the sine function, cosine function, and the arctangent. I've shown the power series for each of these functions below. To the right, we have the power series for the sine and cosine. For the sine, x starts at x, and for cosine, x starts at x equal 1. For the sine, I equals 0, and for the cosine, I equal -1. This allows us to use the same code for both functions. If the angle is greater than 45 degrees, then we switch from the sine to the cosine because the sine of 90 degrees minus x is equal to cosine of x. We save the values of each term in the series so that we can add the smaller numbers first to get better accuracy. You also note that the multiplication by minus x so that we can alternate signs. The angle is in degrees, so we have to convert it to radians. So you can see the factorials being developed here, and you can see that we're moving in steps of 2, so we don't hit every power of x, we hit the alternate powers of x. And then when we're finished, we take and add in the answers starting from the smallest values to the largest values. So what we begin with in our function is that we have the sine and cosine are calling the same function, except for the sine it calls it with 0 and the cosine it calls it with 1. And we begin our function by setting up our array. We put in pi because we're going to have to convert from pi to radians. And we have our indicator to indicate whether it's sine or cosine. If it's greater than 45 degrees, we subtract the angle from 90 degrees and switch over to the other function. Convert the angle to radios, get the square, and then we start our function, and we now use that sine cosine indicator to start either at 0 or -1. Okay, and then we begin our series. We start off going through this actually 7 times since we're jumping through, and you can see how we're building up the factorials as we go along. To find the arc sine, we use the power series on the right to allow us to use less terms in the power series, use the sine and cosine of half angles to make the input value smaller. Since we have to have the angle at the end, we multiply by a factor of 2 to correct for the halving. So what we see here is a function, again, which looks very similar to the sine and cosine function, except there's a little different way that we handle the factorials. Now we look at the full function itself. We see where we start off with, if the angle is less than 0.35, we have the angle and we set the scale factor to 1. If it's greater than 0.35, then what we, remember we're doing the arc sine, so we're about a third of the way to 1, which is what the maximum arc sine that we take the value of. We now use the formula for halving the angle. We now use the formula for finding the half angle by taking 1 minus the cosine of the angle divided by 2. And what we've done here is that we've looked at different values to decide how many times we want to halve the angle. And as we get closer to 89 degrees, we are starting to, we now go finally to the cosine function. Okay, and then after we've done this a number of times, we then have a value that is been cut in half several times. Now the value is not actually cut in half, it's actually the angle that is being cut in half that we're going to get as the answer. So now we go through this function, and we go through it because it's a slow convergent function. We go through it a number of 16 times, and again, use the formula. When we get the answer, we take and reverse the values, and then we multiply by the scaling factor for the number of times that we have the angle. And it turns out that this is surprisingly works out well. Over here, we show the sine of the half angle and the cosine, and you can see where we have a minus, where we had x here, we had a plus x. Okay, so this is and another trick we use is when you take the when you take a squared minus b squared, you want to write that as a minus b times a plus b because of the limited accuracy that the computer has. And so these little tricks that we use in mathematics made it much easier for us to solve the problem and get accurate answers of very high accuracy. Over here, we now show the output checking the functions. And so what we did is we used the sine and cosine, and to check them, we squared the answers. And then to check that they were correct, or to check the arc sine function, we then took the arc sine functions to see if we get back the original functions. And these things are good to about the 13th or 14th place. The knowledge of the sine and cosine function was important in allowing us to improve the speed and accuracy in programming these trigonometric functions. For the sine function, we made use of the 90-degree minus theta, and the same for the cosine function. And for the arc sine, we made use of the half angle formula. Thus, in programming these functions, we got to understand them better and develop tricks to make it easier to evaluate the power series. But most importantly, well, we can find that the sine of 89.999 to 10 or 15 decimal places. We cannot find the inverse to 15 places because of the sine curve flattens near 90 degrees. This was something that was never made obvious when learning the sine functions. So as a result of having a function that can now program this, also understand the trigonometry and the application of the different formulas we learn much better. Thank you again for your attention. See you in our next video.